Okay, so this is review number 2, and we're starting with problem 3. Okay, all right, so we're doing this because we didn't do it before, not because you got a specific question about it, right?
Yes.
Okay. Right, and I'm fine with that. I'm fine with that, but we need to make sure we're getting your actual questions answered, though. End behavior asymptote, number 3, what's the end behavior asymptote? Okay, well, how do you find an end behavior asymptote? Well, first of all, it could be horizontal. Is this one horizontal? No, because the power on top is bigger. So therefore, it's going to be some kind of slant asymptote, which means we're going to have to do what? Divide. We're going to divide. Guys, let's wake up and smell the coffee here. Let's focus. We're going to do synthetic division, and that's going to give us our slant asymptote, our end behavior asymptote. And what will it be? Y equals 2x plus 2. This is the remainder and has nothing to do with the slant asymptote. So the slant asymptote is y equals 2x plus 2. All right? And that's it. That's all you had to do is, what is it? There it is. That's the end behavior asymptote. All right, what are the excluded values? Okay, well, what are excluded values? And what, just in general, what are they? Excluded values are what? Things that make the denominator 0. All right, so look at problem number 4a. What makes the denominator 0? 0 and no, guys, x squared plus 4x. How does that factor? X plus 4. What's going to make it 0? 0 and negative 4. Oh my gosh, you guys, set that equal to 0 and solve it. X equals 0, x equals negative 4. You can do that. That's easy. 0 and negative 4 make your denominator 0. Well, let's perk up. I know it's Friday, and I'd rather not be in math class. I'll think there's something wrong with you if you feel that way. But we got to get this done. All right, B. What's going to make the denominator 0? No, if I put in negative 3, I get 18. There is nothing that's going to make it 0. Because if you have x squared plus 9, think about it, if you square something and add it to 9, are you ever going to get 0? No. There are no excluded values. Now, you can solve that. You can set that equal to 0 and solve it, but what kind of answers will you get? Imaginary. And we're not talking about imaginaries here. We're talking about where would I put vertical asymptotes. Well, there won't be any in this problem. How about C? 0. The only excluded value is 0 because the only denominator is x. All right. Now I'm creating a box to hold all my stuff, or somebody is, and the box is 24, the paper is 24 by 30, so we're going to make a box like we always do. We're going to cut out the corners. Don't know how big they are, we're going to figure that out. But we need the volume of the box to be at least 1,000. So the volume must be greater than or equal to 1,000. Would you agree with that? For some reason this is like magnified and I want to make sure I can see that over there. How come it's magnified? Does anybody know what that's about? Yeah, but it doesn't ever do that. Did I press something accidentally that made that happen?
You might have zoomed in. If you try to zoom out, maybe.
Put your 2 fingers together on the screen.
Okay. Oh. Thank you.
You teach us, we teach you.
Yes, this is truly a collaborative atmosphere. Awesome, thank you. Okay. All right, so the volume has to be bigger than 1,000. All right, so we've done this, we've probably done it 20 times. What's the equation for the volume of this box going to be? Length times width times height. What's it going to be? 30 minus 2x times 24 minus 2x times x, and that has to be greater than or equal to 1,000. Now, this is different than the last time we did these problems, because the last time we did them, we were looking for the maximum volume of the box. Here, we don't necessarily care that it's the biggest it can be, we just need it to be bigger than 1,000, right? So, we're going to approach it very much the same way. We're going to graph two equations on our calculator. We're going to graph this, like always, but then we're going to graph a second equation that's just y equals 1,000. So we're going to have two equations entered in our calculator, one the box volume, and the other one 1,000. So go ahead and put those in. Please don't press graph until we set our window appropriately. So one equation is the volume, the other one is 1,000. Right, now I'm going to go to my window. Every time we did a box problem, we set up our window so x was between a couple of numbers. What is the minimum x and the maximum x for this particular piece of paper? 0 and 12. So x min is 0, x max is 12. That is also known as the domain of the problem. That's my domain. Now, what about my y's? What's my minimum y? It's volume. What's the minimum volume? 0. Now, I don't know what the maximum volume is, but I know I need it to be at least 1,000. So I'm going to go ahead and make it just randomly 1,500. That may or may not be big enough. It doesn't matter to me. I'll change it if I need to. But I'm picking a number bigger than 1,000. Okay, so now I hit graph. Hopefully what you see on in your screen, actually it goes clear to the top, but it doesn't matter, is something like this. This is the 1,000 line. So the volume equals 1,000 at these two places, and it is greater than 1,000 in those places. So that's going to be the answer to the question. So I need to find these two endpoints. So I'll go to second calc, and what will I choose if I am looking for that point right there? Intersect, and I'll set my left bound and right bound like I always do. And I got, what is that, about 1.88? That x value is 1.88? Someone nod? Okay. And then I got to repeat it, so I do the second calc again, because I need the other side also. And it's 7.56. So now I need to answer the question, which was how big must the cutouts be? So that's x. X is the cutouts. How big does it have to be? Between 1.88 and 7.56, don't they? In that interval right there. That's where the cutouts will be bigger than, that's where the cutouts will create a box bigger than 1,000 cubic inches. Got it? Okay. Next, that was A, now we have B. Now we got a mixture problem. mixing lemonade. What is our general format for mixing lemonade, or mixing anything? Amount times percent plus amount times percent equals amount times percent. Alright, so here we go. Let's fill in what have I got. I got Bob and Max. So I'm going to kind of, okay, so I got Bob and Max. So I got 27% here. And Max is 15% here. And, oh, this one's a little different, isn't it? Bob is dumping in 18. Max is dumping in 28. Okay. I want to know what is the percentage of the mixture. So now my X is what's the percentage? What's my amount of the mixture? 46. Kids, don't make it hard. You dumped in 18 and 28. So you're going to end up with 46 ounces of it, right? So it's exactly the same kind of problem, but our variable's in a different spot than usual. So 18 times 0.27 plus 28 times 0.15. So this is 9.06 equals 46x. So x equals about 19.7%. It says what is the percentage? So I'll change my decimal to a percentage. Did you get that? That was easy. Right?
Doesn't matter what you round.
Well, no, because I didn't give any directions. What, on the test I'll probably give you directions. All right, C is one of those things where we're working together to accomplish a task. Did we talk about one of these the other day? Okay, have we done this problem actually?
Yeah.
We did this one? Okay, let's do another one just in case. I'll just make one up. Susie can do it. Susie can do it in 3 hours. Bob can do it in 7 hours. How long together? All right, so there's just the skeleton of the problem. So whatever it is we're doing, takes one person 3 hours, the other person 7 hours. How long will it take them together? So what would be the setup? 1/3 plus 1/7 equals 1/x. Because our general formula, just like this is a general formula for the mixtures, our general formula is 1/alone plus 1/alone equals 1 together. So the variable might be, the question is, it might be a different question. It doesn't matter. 1/alone, 1/alone, 1 together. Put your variable wherever it belongs. Then solve it however you want. It truly, who cares how you solve it? I'm going to multiply everything by 21x just because that's what I do. I like to do that, but you can do it other ways. This will leave me with 7x plus 3x equals 21. So 10x equals 21 and x equals 21/10. So it takes them just over 2 hours to do the job alone. Easy. All right, and then D. Math department's minimizing poster board, the department's having, okay, so this is one of those where we have we done this one?
No.
Okay, where we have, we're gonna make something, a poster or something, and we're gonna have print in the middle of it, and then we're gonna have a margin around the edge. And the middle of it has to have 144 square inches. And then we have to have 1.4 inches on the left, 2 inches on the top, and 1.75 inches on the bottom and right. Okay? You all right with that? Okay. Now, what do we want to do? We want to find the minimum area. So we need an equation for area. How do we find area? It's a rectangle. Length times width. So we have to take this, we have to figure out what that is, we have to figure out what this is, we're going to multiply them together, and that's going to be my area, right? Now, I know, let's look at this dimension first. I know I've got 1.4 and 1.75, but then I also have this, right? And I don't know what that is, so I'm going to call it x. So my width is 3.15 if I added right, plus x, because I have my 1.4, my x, and my 1.75. So that's my width. Now, what's my length? Well, I know I got a 2 up here and a 1.75 down here, so I know I've at least got that much, right? Then what else do I have? This. Now, don't call this x, because if you call this x, you're telling me this is a square, because you already called that x. Now, could that be a square? Yes. Do I know it's a square? No. So you can't call it x, you have to call it something else. And whatever you call it, it has to times by x and give you 144, because the area of this is 144. So what can you multiply by x and get 144? 12 times x is 144. 144 divided by x. What happens when you multiply 144 over x times x? The x's cancel and leave you with 144. Think of it like this. These two times each other are 144. That means that if you knew this was like 20, how would you find your width, or your length? Would you take 144 and divide it by 20? That's what we're doing. I'll take 144 and dividing it by x. So this dimension is 2, 1.75, and 144 over x. So it's 3.75 plus 144 over x. Now that is what I want to minimize. This time we're finding a minimum area. So I'm not going to multiply it out. I'm just going to type it in. So I'll get rid of the other things. I type it in exactly as I have it written up there. That's fine. Don't need to FOIL it out. You might just make a mistake. Get rid of 1,000. We don't need that in there anymore. Now, I have no idea about a window, so I'm just going to press graph and see what happens. I got a shape. What am I looking for? Read the question. What are you looking for? You're looking for an intersection? No. You're looking for a high point? You're looking for a low point. I'm not seeing it on what's on my screen, so I'm going to go ahead and change my window, and I'm going to make my x's a little bit bigger. I'm going to make my x's 30. Notice I'm not panicking. I'm just changing my window. Oh, 30 helped. Tell you what I'm going to do. I'm going to make it even bigger and see if it helps even more. I went ahead and made it 100, and now I can see a little more clearly. Do you have something that looks like a swoosh? My minimum's down here somewhere. So how do I find the minimum? Second calc. Go down to minimum. Set my left bound and right bound. And my minimum looks like is, I gotta round that off to 11, and 238.3. That's my minimum point if I round it off, which I really have to. Because it was like 10.99988 or something.
What did you do?
What? Okay, well, check your equation. I know I'm right. Okay? Now, what's the answer to the question? What's the minimum area? So I got two numbers up here. Which one of them is the minimum area? $238? How do I know that? Because when I set up my equation, what did y equal? Area. What did x equal? The dimensions of the inside here? So this is 11. The area is 238. That's the answer to the question. Okay, so what's the issue? Why are we all, what's the matter?
Our graphs aren't matching.
Okay, what window do you have?
-100.
Okay, stop right there. Stop. Why, and just think about this. You're telling me x-min is -100. That means you're going to let this value right here go down to -100, right? Does that make sense? Can this be anything negative? No. So what should our minimum x be? 0. Absolutely. I'm not saying there isn't more to this graph. There absolutely is more over here, but we can't be looking at it because it doesn't make sense in this problem. Okay? You have, not you personally, we all have got to pay attention to what you're letting x and y stand for. That's going to set up your window for you. In this case, x-min and y-min have to both be 0. It makes no sense to have x or y be negative. Now, will something graph there? Absolutely, you're going to get a picture there, but it doesn't have to do with this problem. Right? So, let's set our window correctly and look at the right part of the graph, and then we'll see what we need to see. Now, when your teacher is standing up here, and sometimes I'm not totally confident, but I'm totally confident I'm right here. When she's standing up here and she's saying, this is what this picture looks like, and you're not getting that picture, then there are two things that can be wrong. One is your window, and the other is your equation. So make sure you type the equation in correctly. Make sure you use the window. I said I left my window the same as I had it for the last problem. You obviously changed yours. And then I made my x max bigger. I took my x max all the way, ultimately, all the way to 100. Now that was way too far, but it didn't matter. I took x max to +100. So now you should be getting something that looks like that. Okay, did we finally get something that looks like that? On test day, I'm not going to tell you what the window is. You have to figure that out on your own. Right? Okay. We're only looking in quadrant 1. Now, if there's a problem that says sketch, or not necessarily says sketch, but where you're solving with your calculator. So I'm making this one up. I'm making this totally up, so I have no idea what's going to happen. But if you have an equation like this, x squared plus 5/x minus 3 equals 0. If you have an equation like that you need to solve, it's not part of a word problem, it's just a random equation to solve, then you want to have a window that includes all the areas, because x in just a regular equation, x could be negative, right? Nothing wrong with that. So I would sketch that in a standard window first. And what's the standard window? Negative 10 to 10. I would just start with that. Now again, I made this up, so I have no idea what it's going to look like. But I'm going to graph it in a standard window. And I get something that looks like this. Now, okay, the directions to this say solve. And it's on the calculator page in the test, which means I know I can use my calculator, so I graphed it. Now, what would I be looking for if it said just solve this? What am I looking for? Where it crosses the x-axis. Now, it appears to only cross in one place, right? Which is fine. That means the other answers are imaginary. I have one answer, it's good. And how would I find that one answer? Yep, I go back to second calc, just like I have a million times. So back to second calc, this time pick 0. And set my left bound and right bound. And that one is negative 2.28. So the only answer to the problem would be negative 2.28. What if when I hit graph, because I have no idea because I made that up, what if when I hit graph, I hadn't seen it cross the x-axis? What would I want to do? Change my window to make it bigger so I could see where it crossed. What if the problem had been this? Would I have changed anything I've done up to this point? Nope, I do this exactly. But my answer wouldn't be x equals negative 2.28. No, that's not the answer anymore. What's the answer if it's less than? This is the part of the curve that's less than. Would you agree with me? That's the only part of the curve that's under my arm. So let's see, how am I going to write that as an answer? It starts at negative 2.28. Where does it end? There's an asymptote right there. See that in the denominator? There's an asymptote right there. Where does it end? 0. There would be the answer. All the x's between negative 2.28 and 0. You've got an asymptote at 0. Your calculator doesn't like dot it for you. But can you see that asymptotic behavior there? Makes perfectly good sense. X can't be 0. Okay? All right, so that finishes that page. All right, what else? What other questions do you have? Review 1 is on video, and so is those extra problems on page 6. I can't remember if I did that with you or somebody else, but that's on video too, page 6, which is just more extra problems. So, looking at that, looking at anything else in the packet, what do you have a question about? I think we have 8 more minutes, maybe? Yeah, we have 8 more minutes. We can do several problems in 8 minutes. So what do we need to do? Chandler?
On review 1, can you do 2B?
Review 1, which is page 7. 2B.
Yeah.
Find the zeros. Now this is on the no calculator part of the test. So basically when it says find the zeros, we're doing the same thing we were doing down here, but we're going to do this without a calculator. So, okay, so what do we do if we have some big, huge problem like this and we have to find the zeros? What do we do?
Divide.
We're going to figure out something and divide it out. So our only possibilities are the plus or minus 1, plus or minus 2. So, looks like 2 might work. Let's give it a shot and see. I don't know. Oh.
Negative 1.
Oh, it's too late now. I'll get that one in a minute if this one doesn't work. But that one did work, okay, I think. Did I do that right? Or was that just wishful thinking on my part? I think that's right. So what's left? X cubed plus x squared plus x plus 1. Now, that one factors by grouping if you want to do that. Some of you have already noticed that a factor of -1 worked. So if you know -1 works, you can divide it out. If you don't see that, you can factor this by grouping. When you can't take anything else out, take a 1 out. We should have 4 answers to the problem. We guessed that one. We get -1 from this one, right? Just like some of you guessed that number. And what does this give us? Set it equal to 0 and solve it. What does it give you?
1 and -1.
No, it doesn't give you 1 and -1. Plus or minus I. We don't need the root 1 because root 1 is just 1. So you set that equal x squared equals -1, x equals the square root of -1, plus or minus I. So if we graphed this, we would cross the x-axis here and here, right? And then just have some squiggly somewhere because of those imaginary roots. All right, anybody else? That's a good one to do. Anybody else? See
Wait,
anything on review
this is
2 or
what?
one of the other review sheets, Abby?
Review 1, number 3C.
3C. Now the nice thing about 3C is it already has a 0. Remember with your inequalities, you always want to have 0 because everything's about positive and negative when you're dealing with inequalities. You already have a 0. So this one's all set up. I'm going to go straight to the number line. I'm going to put 3 dots on the number line. Where are the dots going to be, do you think, in this problem?
-2.
1 will be at -2. 1 will be at 0. And 1 will be at
4.
not 4,
-4.
-4. So I have one at -4, -2, and 0. There are the dots. Remember, the dots come at the places that make 0. If you can't eyeball it, solve it. Okay? Now, normally we pick 0, but we can't this time as our test point because you can't pick a dot. So we're going to pick some number other than 0 to test so that we know where to shade. So what would you like to pick? 1. 1's a good number. Now 1's out here. So if I put 1 in, I'm going to have 15 over 3 times 1. Now I don't even care what that is. I just want to know, is it less than 0? No. So therefore that doesn't work. This does, doesn't, does. Now, should any of my dots be colored in, or am I good with them all open like that? The only one that's colored in is this one right here, because that one came out of the numerator. You cannot let x be -2. You just can't. You can't have a 0 in the bottom. So those dots are going to have to stay open. And your answer is everything from from -infinity to -4, or from -2 to 0. Got it? All right, we have time for one more, quick one. One more. Anything else we need to talk about real quick? Which one? 2C. 2C says find the roots or find the zeros. It's exactly the same as the other one. We're gonna have to guess. Now, the only thing that's a little bit tricky about this one is, when you guess, and I can see that the number 1 works, when I divide it out, watch the division there, you're gonna have to put a 0 in, because you've got a power missing. So, and there it is, so I know that works. All right, so one of my answers, and there are gonna be 3 of them, one of my answers is 1. Now, how am I gonna find the other 2? I have x squared plus x plus 7. Oh, no. What am I gonna do with that? The quadratic formula, x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Negative 1 plus or minus, all right, what have I got under there? Negative 27, which is 3 root 3i. So 3i root 3. So there's 2 answers, and there's the 3rd one, and we are done. All right, Quentin, would you turn that off?
Yeah.
All right, next time I see you,
Oh, yeah.
Monday, I